Hey everyone, welcome back to another Introduction to Algebra video, where we'll go over the exponent rules, and in particular, the negative exponents. So, the way we deal with negative exponents is if we have any number base b to the power of negative n, that's just going to be the reciprocal. So it's going to be 1 over b to the power of n. And let's try to think about it. So what I'm going to do is I'm going to set up some exponents and see what happens. So 3 to the power of 3 is 27. 3 to the power of 2 is simply 9. 3 to the power of 1 is just 3. And 3 to the power of 0, it's not exactly 0. And this is where we'll take a quick detour. So you see here that we're dividing by 3 each time. Or we're going up where each time we go down. Or we're multiplying by 3 each time we go up. And that's just how exponents work. That's a fundamental property. So it makes sense that if we're going to keep on dividing, when we go down, that means we must divide when we go down from 1 to 0. So 3 divided by 3 is simply just 1. And now that might not make any sense. If you're taking a number and multiplying by itself 0 times, that's just 1. That should be 0, but in fact it is just 1. And that's how it is. And that's the case for every other number, not just 3, except for 0. When it is 0 to the power of 0, we call that undefined, or indeterminate. But every other real number to the power of 0 is simply just 1. So now let's continue. That means 3 to the power of negative 1 must be 1 divided by 3. And 1 divided by 3 is 1/3. And we notice something here. This matches up with exactly what we saw in the exponent rules over here. In this case, b is 3 and n is 1. So 3 to the power of negative 1 should theoretically be 1 over 3 to the power of 1, which is just 1 over 3. And we can continue this. We divide again. This gives us 3 to the power of negative 2, which is 1 over 9, because 1 over 3 divided by 3 is simply just 1 over 9. And that's exactly what the exponent rule here tells us. 3 is b and 2 is n. So this must mean that it is 1 over the base, which is 3 to the power of n, 2. And that's exactly the case over here. So we see how the negative exponent rule works. So now let's take note of something else. What if we have 1 over b to the negative n? What is that going to be? Well, let's try reasoning it out and see what happens. So now we're going to utilize complex fractions, where we have fractions inside of fractions. So the numerator is going to remain the same, which is 1, but b to the negative n can be rewritten as 1 over b to the n. So on the denominator, our denominator is going to be b to the negative n, just b to the n, 1 over b to the n. And in order to clear out the denominator, we just multiply the whole thing by its reciprocal. So this is just going to be 1 divided by 1 times b to the n divided by 1. And that just leaves us with b to the n. So that gives us another fundamental fact that we can use. 1 over b to the negative n is simply just b to the n. So if it's on the numerator, we just take it down to the denominator, and if it's on the denominator, we just take it back up to the numerator. So the negative exponent can just simply be seen as a method of flipping the base and the exponent across the numerator and the denominator. So I hope you guys understood how negative exponents work, and maybe apply to different situations and in different contexts. And in the next video, we'll look at a more complex example of exponents where we apply many different rules together.